Okay, here's our last video covering the last two questions on the test. Question 9 is exercise 43 in section 5.2 on page 268 of our text, and it's an application or word problem, and it describes a ski manufacturing plant that manufactures trick skis and slalom skis. And it requires 6 hours in the fabricating department for the trick skis and 4 hours in the fabricating department for the slalom skis, and each ski takes 1 hour to finish. Total labor hours available in the fabricating department is 108, and total labor hours available in the finishing department is 24. So we can represent this with an inequality. 6 hours for each trick ski, and we're using x as the variable to represent the number of trick skis, and y to represent the number of slalom skis. And so 6 hours for each trick ski plus 4 hours for each slalom ski. Those total hours can be no more than 108 in the fabricating department. Then in the finishing department, 1 trick ski and 1 slalom ski, or 1 hour per trick ski and per slalom ski. The total there is no more than 24, less than or equal to 24. And of course, the number of trick skis is at least 0, so it's greater than or equal to 0. The number of slalom skis is at least 0, so we have that inequality as well. Y is greater than or equal to 0. And so to plot the feasible region, of course, we're going to be shading the area to the right of the y-axis, and because those are all the values that are of x that are greater than or equal to 0. And we'll be shading the area above the x-axis, because those are all the y values that are greater than or equal to 0. And then we need the lines that correspond to these inequalities. And so for the first one, 6x plus 4y equals 108, we do change that into an equality to solve for the equation. And we can see that when y is 0, then 6x equals 108. We divide both sides by 6, and that gives us x equals 18 for an x-intercept for that equation. And so we would plot that point here. That's our x-intercept. And then to sketch the line, we would then need either the y-intercept or perhaps another point on the line. And if I choose an x value of 6, I can substitute that in here. 6 times 6 is 36. And I subtract both sides from 36 from both sides of this equation and divide by 4, and that gives me y is equal to 18. So when x is 6, y is equal to 18. There's 2 points on the line, and we can then plot the line. We can sketch the line. Y-intercept, by the way, would be 27, but that's off the scale of the graph I have here. So that's one line, and then the other line, x plus y equals 24, is just, that's got a y-intercept of 24, and a -1, a slope of -1. And so I go down 1, over 1, down 1, over 1, down 1, over 1, and I see that 6, x is 6, y is 18, is a point on that line as well. So that's where these two lines intersect, and this area that's enclosed below those two lines, and again, as I said, to the right of the y-axis and above the x-axis, that whole shaded area is the feasible region or the solution region for this system of inequalities. It represents the feasible region at that ski manufacturing plant. And then the last question asks the last question asks us to maximize some value given by this formula on this region here. Well, as I said in class, that value is going to attain a maximum at one of these corner points. There's no way we're going to have a maximum anywhere within the region. We have to go to a corner point to find the maximum. So what we do in this case is evaluate each corner point by substituting in the x value and y value for each, and then add those two, and that'll give us this value z. What is z? It's abstract in this case. It doesn't stand for anything other than the value of this expression here. So the points, the coordinates of the points are very easy to determine, and even though they could be extremely close to these values, but not exactly those values, I will tell you that that for purposes of this exam, the points are exactly what they look like. In other words, this point is has an x value of 2 and a y value of 3, so that's exactly what it looks like. That's exactly what it is. This point here has an x value of 3 and a y value of 7, and this point here has an x value of 7 and a y value of 4. So here you see the calculations. If you substitute a 2 for x here and a 3 for y here, 6 times 2 is 12, plus 2 times 3 is 6. So 12 and 6 is 18. So that's the value of z at this point. Then at x is 7, y is 4. 6 times 7 is 42, plus 2 times 4 is 8. So 42 and 8 is 50. So that's the value of z at this point. And then at this corner point, x is 3, y is 7. That's 6 times 3 is 18, 2 times 7 is 14, 18 and 14 is 32. So the value of z is at this point is 32. And so we have a maximum on this region of 50 at the point x is 7, y is 4.